Hello, guys, welcome to Coding Simplified. And today we are going to start a new series which is on data structure. So, first, we need to understand what is data structure. So, data structure is basically storing a data in a different form or in a form so that it can be used efficiently, right? So, let's take an example that whenever you are creating a database or whenever you are solving a problem. So obviously you will have so many data to insert or delete or search, right? So as per your application, you need to define or you need to arrange your data in a structure so that it can be used efficiently, right? So for example, let's say you are making an application where you need to only insert data, right, and only delete data. You do not search your data so frequently. Then you can use linked list, or you can have the application where you are searching more rather than inserting and deleting. Then you can use the array, right? So you need to define your structure efficiently, right? Or let's say in interview, people ask you, okay, what would be the best way to store this data as per your problem. So whenever you are solving any problem or whenever you are defining any application, first think that which data storage or which data structure is efficient for you. Like whether it is arrays okay for you or it is list which is okay for you, whether you should use stakes or queues or trees, or whether you should use heap or graph, right? So we will study each things one by one, right, and we will think which is best for you, right? So whenever you are making an application, you need at least three operation, right? Suppose you have a company database, so either you will insert the employees database or employees details, or you can delete the you want to delete the details, or you want to search an particular employee, right? So with each data structure, we will study that how it is efficient to insert, to delete, to search, and then we will do other operations, right? So in insert, so what could happen? Let's say we are using array, right? So first we will declare the first element or the first array, right? So we can insert at the end, or we can insert at the given position, like insert at third position or fourth position, or we want to insert the employee detail at the starting. Same as the delete case, we want to delete from the end or from the given position or from the starting index, or you may be given element value, right? So then in this case we need to search the element value first, and then we will delete, right? So again, for the searching, we will have so many algorithms. So which algorithm is best, that we need to use in our application, right? So there can be linear search or binary search or other way of searching which could be best for your application, right? And then we'll use the other operations, for like we'll use the like reverse the all elements, or like merge two arrays or merge two linked list, or then find maximum element or minimum element, right? And then we'll do other operation. So for the each operations, for each data structure, array, linked list, stack, queues, one by one, first we will do the insert, then we will do the delete, then we will do the other operations, right? So in this way we will do all the things, and or we will study all the data structures, right? And we will know that what is the difference between each data structure, right? So just from the glimpse, like if you take example of array, right? So the size of array is fixed, right? You need to give the size as a starting, right? I have this 100 employee, right? So you give an array that okay, the size is 100, right? But the problem is, let's say if 101th employee is coming, then you need to declare or you need to define array again, right? Because the element size is fixed, Or let's say you have declared the size at the starting 1000, but the employee is only 300. So this so the memory is vesting at that particular uh, till the those employee comes, right? So this is the this is a shortcoming in array. But in list and trees, so we need not to define the size at the starting, right? So let's say if another employee come, so we just create a node and then we'll add in the list or we'll add in the tree, right? So this is the important thing, that we use the that why we should use the list or tree over the array, right? But then if you compare the memory, so array only takes that memory only for that element. Like if your array is of string, so it will take that string, that particular string memory, right? Not for, like the for the complete node. Because list, so list contains the pointer variable also, right, for pointing to the other variable of the list, or same as a tree. So this memory is not vestige in the array, right? And then you need to define that whether in your application insert and delete is more. Because if you are taking array, then in array insert and delete operations are very difficult. Because first you need to, because if you are inserting, then you need to go all through the and, or suppose if you are want to add and the middle, then first you need to go to that particular element or that particular index one by one, right? And then you need to shift the values. So insert and delete are difficult to operate, but in list and binary tree it's very easy, right? But the search is faster. So depending on the algorithm, search is faster in array, but in list it is little bit slower. But in trees, in tree also it's okay than list, right? But slower than array, right? So depending on the algorithms it varies, right? So we will study all the things about the data structures, that all their pro and cons, whether we should use this array or list or trees, right? So the bottom point is that whenever you are solving any problem, first think that which data structure I should use for this particular problem. So one problem can be solved in many ways, right? Like we can, like queues. So queue and stack can implement using array as well. It can implement using linked list also. So we need to think that which operations will need more, and then we'll use our data structure efficiently, right? So first we'll study the arrays, then we'll go to linked list, then stack, then queues, then trees, then heap, and then graph one by one. So thank you friends for watching the video, and in next tutorial we'll start from the array, where we'll solve all the problems regarding array one by one. And for more information on data structure, you can visit the codingsimplified.com site. So that's it in this tutorial, and please like the video and subscribe the channel. Thank you.